Good morning to all. In the previous lecture of CRE, we discussed about the porous catalyst and which types of porous catalyst available, and in which we discussed the criteria, selections. Okay, so then after we discuss fourth term, it is the relation between efficiency and thrilled modulus. After the relation is given that so efficiency can be defined. Now we define the quantity eta called it is called effectiveness factor in order to measure how much the reaction rate is lower due to the resistance of pore diffusion. ઓકે, અત્યારે શું કરીએ છીએ આપણે એફિશિયન્સીને ડિફાઇન કરીએ છીએ અને એફિશિયન્સીની જગ્યા પર કહી શકીએ એને ક્વોન્ટિટી. સો ઇટ કેન બી ડિફાઇન્ડ એઝ અ effectiveness factor, okay, in order to measure how much reaction rate is lower, કેટલો લો હોઈ શકે છે. So in the absence of pore diffusion resistance, so efficiency, or it can be the quantity, it can be defined by this ratio. So it is the defined as the ratio of actual average reactions rate within the pore to the reaction rate in the absence of pure diffusion resistance. એટલે કે ટૂંકમાં જોઈએ તો actual average reaction rate બરાબર, actual પછી એવરેજ અને એ પણ રિએક્શન રેટ શાના અંદર, તો કે પોરની અંદર, વિધિન પોર. ઓકે, ધેન સેકન્ડ કોની સાથે રેશિયો છે, તો રિએક્શન રેટ ઇન એબ્સન્સ ઓફ પોર. પેલું છે પ્રેઝન્સ ઓફ પોર અને આ બીજું છે એબ્સન્સ ઓફ પોર of diffusion resistance. Okay, so it is given by this here. Efficiency is actual average reactions rate within a pore divided by reaction rate in absence of the pore diffusion resistance. Okay, so equal to average reactions rate within the pore divided by reaction rate that must be that would be result in entire pore surface were exposed to condition that external surface or a pore mouth, that is CAS and TS. So simply said that કરીએ તો શું થશે, efficiency is equal to -RA bar with diffusion અને divide by -RA without diffusion resistance. Okay, so the rate of reaction in the absence of pore diffusion resistance is the maximum rate of the reactions. જ્યારે rate of reactions છે ક્યાં પોર ડિફ્યુઝન રેઝિસ્ટન્સના એબ્સન્સમાં હોય ત્યારે રિએક્શનનો જે રેટ હોય છે it should be a very greater. Okay, so the reaction rate is very high. The rate of reaction will be maximum when the concentration of reactant along with the pore is same as that external surface. Reaction rate maximum ક્યારે હોઈ શકે છે? So first in that case કે જ્યારે concentration of reactant along with the reactant along with the same as that external surface. So that is efficiency is equal to -RA bar with diffusion and RA without diffusion resistance. Actual rate is also referred as the observed rate of reaction, that is Ra observed. Effectiveness factor is ranges from 0 to 1 only. That's it. For the first order reactions, since the rate is proportional to the concentration, the effectiveness factor is given by. So the first order reactions, the rate is given by the proportionality, that is Ca bar divided by Cas. And then evaluating the average rate in terms of 4 reactions, so it should be yield from the relationship it given by nth efficiency of first order reactions is given by C by Cs is equal to tan H of ml divided by ml. Okay, now let us complete more. It will be, so this phenomena is simply it's a mathematical expressions. So it is given by Ca bar upon Kca, that is Kk will be cancelled, Ca bar upon Cas. Now Ca is given by, Ca की वैल्यू क्या होती है? Ca की वैल्यू होती है इंटीग्रेशन ऑफ 0 to L Ca of dx upon 0 to L dx, that becomes 1 upon L integrating from 0 to L Ca dx. With this Ca value, this equation 6.16 is becomes, so Ca ની જગ્યા પર વેલ્યુ મૂકી દો 1 upon L CAS અને બાકીનું as it is, that is 0 to L Ca dx. Okay, so we have the value of Ca upon Cs, that is cos H ml. ml की जगह पर શું અહીંયા શું આવશે? L minus x, and bottom part as it is cos H ml. So from this Ca is equal to Cas multiplied at the Cs cos H ml minus x cos ml. Now substituting the value of Ca into equation 6.17, Ca into equation 6.17. So Cas gives first order reactions 1 upon L Cs 0 to L Cs cos m L minus x dx upon cos H ml. So basically it will be common and cancelled, so cos as ml will be common, so remaining term is that Cs from the top side, ઉપરથી Cs common, નીચેથી cos H ml common, તો શું થઈ જશે? cos H m L minus x dx, બરાબર? કોન્સ્ટન્ટ વેલ્યુ છે. હવે ઇન્ટિગ્રેટિંગ ફ્રોમ Cs, સો Cs ની જગ્યા પર 1 upon Cs કેન્સલ, એટલે કે 1 upon L cos H ml, બાકીનું ઇક્વેશન એઝ ઇટ ઇઝ. ફરીથી એને ઇન્ટિગ્રેટિંગ, હવે એને ઇન્ટિગ્રેટિંગ કરીએ તો શું થશે? -1 upon m, एमનું -1 upon m L minus x sin h cos का क्या होगा? sin h m L minus x 0 to L. ओके, एमનું શું થશે? એમનું m raised to -1, that is 1 upon minus m minus 1. Okay, so exactly what happened? Minus will be removed from the bracket, so -1 m will be common, so that is m common લઈએ તો શું થશે? ml cos h ml માઇનસ પછી ત્યાં શું થઈ જશે? આના જગ્યા પર 1 બાય એટલે કે 0 sin h ml. ઓકે, upper limit minus lower limit. Okay, so the basically it will be 0 की जगह पर एक तो 0 જ આવશે અને બીજું આવશે sin ml, x વાળું ટર્મ શું આવશે? 0. so it will be 1 upon cos છે, બરાબર? અહીંયા માઇનસ છે તો માઇનસ માઇનસ will be પ્લસ, બરાબર? એટલે કે sin h ml upon ml cos ml, ml ml will be cancelled, so sin by cos that is tan ml by ml. Okay, so nth first order reaction is given by these equations only. Now the next topic is for that heat effect. So either they are exothermically, that means exothermicity and endothermicity during the reactions. Reaction should be either they are giving the heat from the reaction, either we have to supply the heat to the reactions. Okay. In very first reactions, the heat is released or absorbed, या तो फिर रिलीज થાય છે અથવા તો એબ્ઝોર્બ થાય છે. In the pellet cannot be removed rapidly or quickly. So thus it is not possible to keep the pellet close to the temperature of the surrounding fluid, and this consequently result in a non-isothermal condition such as following cases types of temperature effect may be encountered. જે અગત્યના ટેમ્પરેચર પેરામીટર કેસ છે એમાં, સો પહેલું છે પાર્ટિકલ ડેલ્ટા ટી temperature gradient. Temperature gradient may be exist within pellets. So temperatures vary within the catalyst pellets. catalyst pellets के साथ वो चेंज होगा, वेरी होगा. Film of delta T. Temperature gradient may be exist across the fluid film between the one surface to pellet surface, between the outer surface of pellet and main gas stream. So the whole pellets may be hotter or colder than the surrounding fluid through the uniform in temperature. Okay. So in the case of exothermic reactions, heat is generated and particles are hotter than the surrounding fluid. Consequently, the non-isothermal rates, the reaction is higher than the isothermal rate, which is based upon the bulk stream conditions. On other hand, in case of endothermic reaction, heat is absorbed and the particles are cooler than the surrounding consequently the non-isothermal rate is lower than the isothermal rate, simply from the exothermic and endothermic reaction. Okay. So we would promote non-isothermal behavior in the exothermic reaction, provide the harmful effect of thermal shock or sintering of the catalyst or drop in the selectivity occurs within the particles. On another hand, we would depress non-isothermal behavior in endothermic reactions, and the following simplification calculation will give for the delta T across the film and the rate of heat generation, and the reaction within the pellets is equal to the rate of heat removal through the film. Okay. Delta T, film delta T. To find the maximum value of delta T across the film, the rate of heat generation is reaction within the pellet. It is the set of equal to rate of heat removal through the film. So rate of heat regeneration. So rate of heat generation by the reaction within pellet, it gives by Q generated, like a heat generated, equal to V pellets into R added obsolx into minus delta HR. So V pellets into delta into minus R triple dash of OBS minus into delta HR is equal to the joule per kilojoule per second, where observed reaction rate R dash A observed એ શું રહેશે, observed reaction rate. delta HR શું થશે, heat reactions enthalpy change from the reactions, and V pellet is the volume of pellet, that is calculating by S pellet into L, that is અને L ની બરાબર VP by SP, surface to volume ratio of the particle, and L is the size of the pellets. So it gives by S pellet into L into the NSR radius OBS, observed. Okay, so this will be given as a rate of removal from the film is Q removal, as it is we can find H as pellet, Tg minus Th, as is film coefficient. Tg is the temperature of main gas stream and Ts is the temperature of outer surface. So Q removed by Q generated, so it will be H of S pellet Tg minus Ts, and H of pellet into L into delta H. So final equation is that delta T film Tg minus Ts is equal to L into R A observed minus delta HR upon H into K, which is in Kelvin.